Hello, ladies and gentlemen. It's time for a little example from Proofs Practice 2. The point of this assignment is to build your ability to solve proofs or complete proofs that you necessarily haven't completed before. And so, it's just a little bit different. You'll see things like, it mentions things like bisect. You'll have to prove some triangles are congruent. It mentions complementary angles. Remember, complementary means adds to 90 degrees. That's what complementary means. And let's see, we got all sorts of fun things. You have to prove things like the exterior angle theorem for triangles. You can prove some parallel lines. There's lots of different things. It's kind of a mix of a lot of different things. But you, in order to get level 4, need to be able to complete a proof that you have not seen before. So here's a few examples of proofs we have not done in class. And so we're just practicing with them. And in fact, the example we're going to use today is going to be number 6. Because it is a parallelogram proof, but it's backwards. We're trying to prove this thing over here is a parallelogram. So we don't know the sides are parallel. But we're given that these opposite sides are congruent. So MJ, LK, and then JK and ML. So we know that those opposite sides are congruent. But we need to prove that the sides are parallel in order to prove that it's a parallelogram. And so let's get our 2 columns started here. We got some statements. And over here, we're going to put some reasons down. And let's write our givens on there. You just kind of automatically put those on there. MJ is congruent to LK. And JK is congruent to ML. Now, that was given to us. Hooray, we have a starting point on here. So, before, just like on the previous assignment and all our other proofs, when you need to complete a proof, you should have a plan. Like, what are you going to write? Before you write a whole bunch of stuff, you need to have some idea of where you're going and how you're going to get to the next step. And so our goal here is to prove that opposite sides are parallel, because that'll prove that it is a parallelogram. If the opposite sides are parallel, that proves it's a parallelogram. Well, how do you prove that sides are parallel? Well, you got a few options. You got a couple lines, and there's a line coming through. You can prove a few different options. Let me put some numbers on here. Basically, you can prove any of the inverse definitions for parallel lines that we have in our notes there. So you can prove same side interior angles are supplementary. You can prove alternate interior angles are congruent. You can prove that alternate exterior angles are congruent. You can prove that corresponding angles are congruent. Any of those options are going to work. But if you look at our shape, you may have noticed we don't have like these outside angles. And so we're not going to be using those. Instead, we just have inside kind of angles because, it's a shape. In fact, if I were to just like kind of draw a couple lines on here, we mainly just have these inside angles to deal with. And so we're not going to be using alternate exterior or corresponding angles because those will be outside. Instead, we can use the inside ones. So either we need to prove that these are supplementary angles, or we can prove that we have alternate interior angles. Since I am familiar with a lot of our parallelogram proofs, which do involve drawing a line like this and getting alternate interior angles like that, that's going to be my path. I'm going to prove we have alternate interior angles that are congruent, and that'll show that the lines are parallel to each other. And so that's what I'm going to go with. And so I'm going to construct a line from J to L, and I need to prove that angles like these are congruent. Well, already, if I draw that line, I see I have a pair of congruent sides, and I have the side in the middle, which is going to be congruent by the reflexive property. So I can already see that I'm going to prove these 2 triangles are congruent by side, side, side. And once I've proven the triangles are congruent by side, 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 then I can just say all sorts of things are congruent. So I can say those are congruent, I can say those are congruent, which are going to prove that with these two angles, these two lines are parallel, and with these two lines here, these two angles, that these two lines are parallel. And so that's going to be my path in trying to complete this proof. Draw the line, get congruent by side, 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 and then I can say parts are congruent, which will prove parallel lines, which will prove parallelogram. So we're going to do that. So first step, construct JL. And that's just a construction. I know I spelled construction. You can just connect any 2 points you want. It's not even a fancy construction. And since I got that, I can just say that JL is congruent to itself. And that's the reflexive property. Make sure I'm naming stuff, yeah, JL. Put my tick marks there. And I already said at the beginning that these sides are congruent, so I can actually just jump straight to triangle MJL is congruent to, and you have to do it in the same order, so MJL, that's going to be KLJ. KLJ. And they're congruent by side, side, side. We got two triangles with congruent sides, so all the angles are going to match up now. So now we can say angles are congruent. I'm going to number these. We got 1, 2, 3, and 4. So 2 and 3 are going to be congruent, and 1 and 4 are going to be congruent because they're corresponding parts of congruent triangles. So angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. By corresponding parts of congruent triangles are congruent. So we did all that, but we're not done, because we weren't just trying to prove that they're congruent, we're trying to prove this thing is a parallelogram. Oh, I erased the wrong stuff. Just don't mind me, just making mistakes. It's fine, mistakes are okay, guys. So we got some congruent angles. I'm going to put some marks. Oh, sorry. Mark. Okay, we got some congruent angles. And so since 2 and 3 are congruent, and their alternate interior angles, we have proven that these two lines are congruent. So I'm actually going to mention that angle 1 and 4 are alternate interior angles, and 2 and 3 are alternate interior angles. And angle 4, and I can put comma, angle 2, and angle 3 are alternate interior angles, and they just meet the definition for alternate interior angles. So I'm going to put definition of alternate interior angles. And since the two angles are congruent and they're alternate interior angles, that proves that those lines are parallel. So we got JK and ML on the bottom. So JK is parallel to ML on the bottom. And we got our left and right ones, MJ and LK. MJ is parallel to LK. And that's the, and I'm going to put in parentheses here, inverse definition of parallel. Nice. And since we've now proven that these opposite sides are parallel, we can now say that KL is a parallelogram. And that is, it just meets the definition of parallelogram. Definition of parallelogram. Man, penmanship, guys. So there we go. We did it. We completed this proof that this particular quadrilateral, since the opposite sides are congruent to each other, that's going to prove that it is a parallelogram. So it's like we're going backwards on our theorem, and that's something that can happen. Sometimes you're just given like the results and you have to figure out where you started. So there you go. Hopefully that's helpful.